Hi, my name is Mr. K. Sudhaharan from JKNS Education. I will be going through question number 4, AQA exam board, organic chemistry, paper 2, June 2023, which is last year. There are two different questions. One is naming the organic compounds, which is easy, 1 mark. And the next one is a 6-marker question. So let me go in more detail how to answer the 6-marker question. Question number 4, starting from acrylonitrile, which is undergo electrophilic addition reaction, which is reaction 1 in this 3-step synthetic route with HBr to produce isomer W. The first question was name isomer W. So when you name organic compounds, you number the carbon atom or take the longer chain. In this case, nitrile is a priority carbon, number 1, 2, 3. Therefore, the name of isomer W is starting from on the 3rd carbon, so 3 bromo. There are 3 carbons in air, so 3 carbons. Therefore, 3 bromo propane, which is 3 carbon. Nitrile is your functional group. So 3 bromo propane nitrile is the name of the compound. So this is pretty easy, straightforward, and you get your 1 mark. Reaction 2 is nucleophilic substitution. The nucleophile is your Cn minus, and reaction 3 is reduction of nitrile to a diamine. And I'm not going to go through in more detail of those two, reaction 2 and reaction 3. That's in another video. So we already named the compound, and followed by, I'm going to go through electrophilic addition mechanism and the carbocation and the stability, minor major product, chiral carbon, planar carbocation intermediate, isomers, optical isomers, and racemic mixture. Okay, these are stuff I want to go through today's lesson. Now, when you have acrylonitrile is a alkene, react with hydrogen bromide, is your delta plus, delta minus, due to the difference in electronegativity. The carbon double bond breaks and attack your delta plus hydrogen, and the hydrogen and bromine bond is broken. Therefore, your intermediate is formed is a primary carbocation, which is that. So that is going to be your primary carbocation. So primary carbocation, 1 R group and 2 hydrogen attached to it. 1 R group and 2 hydrogen attached to it. The second step in this mechanism, your bromide ion attack the carbocation to produce your isomer W, which is 3 bromo propane nitrile. So for the 6-marker question, there are 2 marks available to you: the mechanism and the carbocation intermediate. The primary carbocation is very less stable, which produce minor product. So isomer W is the minor product. Therefore, we are expecting to get another isomer when the HBr reacted with your alkene. It goes and produce secondary carbocation, which is the hydrogen going on to the 3rd carbon. So therefore, the middle carbon, so 1, 2, 3, the middle carbon or 2nd carbon is your carbocation, which is your secondary carbocation. So secondary carbocation mean 2 R group and 1 hydrogen attached to it, which is going to produce the major product is your 2 bromo propane nitrile. So your 2 bromo propane nitrile of the structure is this. That's your 2 bromo propane nitrile after the mechanism. So you could have done either the mechanism to make primary carbocation or the secondary carbocation. Now, the 2-bromo-carbocation contain a chiral carbon. So chiral carbon is the carbon which attach to 4 different groups. The 4 different groups are, number 1 is your nitrile, number 2 is your bromine, number 3 is your methyl, and number 4 is your hydrogen. So when a carbon attached to 4 different groups, it's give you optical isomer. Another word for optical isomer is enantiomers. So when you explain what is an optical isomer, they are mirror image to each other and non-superimposable. So simply is that. So this is still your 2-bromo propane nitrile. So that's your enantiomer 1. I'm going to put enantiomer 1. That is your enantiomer 2. So that's is mirror image to each other, non-superimposable. Now, final mark to explain how it forms. A carbocation is a planar molecule. So planar molecule mean all the atoms in the same plane. The bromide ion can attack above or below the plane, which leads to your 2 different isomers. So which lead to 2 different isomers, which is enantiomer 1 and enantiomer 2. That's how it forms optical isomer or enantiomers. Not is part of the answer. The next one I'm going to explain. So what is a racemic mixture? So racemic mixture, when the attack of the bromide ion, or in other words, nucleophilic attack on the carbocation, if the nucleophilic attack is 50-50 or equimolar or equal amount, is form a racemic mixture, which is do not rotate plane of polarized light. Now, so let's go back and check how many marks available to us what we're going through so far. Stage 1, identifying all 3 isomers. So your W or 3-bromo propane nitrile, and this is your 2-bromo propane nitrile. So 2-bromo propane nitrile contain a chiral carbon, which will produce an enantiomer. So that is your 2 marking point. That is your 2 marking point. And stage 2, the mechanism with all the curly arrows, and the carbocation intermediate is another 2 marks. Finally, explain the optical isomers are mirror image to each other, and the 4 different group attached to the carbon is called chiral carbon. Everything explained in word or drawing the structure will give you the next 2 marks. And explaining your secondary carbocation is planar, and equal attack will give you racemic mixture, or the attack can happen above and below the plane leads to optical isomer. So that's the end of the explanation of these 7-mark questions. Hope it's useful to you. If you need any further explanation or further question, please feel free to call us on our website or call through my phone number. Thank you for listening. Bye for now.